Hello, good morning or good afternoon to everyone. Thank you so much for joining today's session on addressing today's two biggest AGV/AMR challenges. My name is Rachel. I'm in the marketing team of BlueBotics, which is a part of the Zappi group of companies. I'm absolutely delighted to welcome you to this afternoon session. Please remember that this session is also being recorded, so it'll be available to watch on demand once again at the end of the session. If you've got any questions at all, please do drop them into the Q&A, which you can see towards the right of your screen, and we'll answer them at the end of the presentation. Note that your questions will be sent privately, but we will answer them publicly if we may. And with that, I am just delighted to introduce our two speakers for today. So we have with us Dr. Nicola Tomatis, who is the CEO of BlueBotics, and Jacques, who is the VP of Sales. I'm really excited that they're able to share their expertise with us. So Nico and Jacques, please take it away.
Thank you very much, Rachel. We are very happy to have the chance to be here with you today, talking about two challenges we have seen on the market. So this great presentation has been prepared by our marketing team. That's why they call it today's two biggest challenges, because we have to have a very good title. There are, of course, many other challenges. We are not saying we know everything, and that's the absolute must problem that has to be solved. But these are two trends we saw in the last year in the market. We are working in the material handling industry since more than 20 years. We work in the automation of material handling. And indeed, in the last few years, we saw these two trends coming out, which are on one side, working outdoor, and on the other side, the interoperability. Now, before digging into these two themes, let us quickly talk about BlueBotics. So, as Rachel said, BlueBotics is a Swiss company that is part of the Zappi group. So, Switzerland, we are those that do chocolate, and Zappi group are Italian, are more in the Parma ham. That's how we work together. Now, in terms of robotics, our vision is to be the reference in autonomous navigation. So our goal is basically to put one of these blue boxes into vehicles in order to automate them. And our mission is to help companies meeting the challenge of vehicle automation. So we are technology suppliers, component suppliers, like the companies in the Zappi group, and our customers automate either their own vehicles that they do themselves, or they buy some vehicles to automate. That's what we do ourselves. Then again, we are part of the Zappi group. So remember that Zappi group delivers a lot of components for the material handling, drive units, motors, the inverters, chargers, and of course also the navigation with us. And we can, as a group, also deliver other components as OEM. This being said, let's start then with the two biggest challenges we have today in the automation of material handling. And I give then the word to Jacques to talk about outdoor operation.
So thank you, Nicola, and welcome everybody. As Nicola said, there are two challenges, and the first one is indeed outdoor operation, and particularly that tricky indoor to outdoor transition. And I'm now going to take you through the problem statement and what we can do about this. So if we move to the next slide, we can see here that automation of fully indoor material handling processes here on the left of this page is obviously now well established. And we have AGVs of different types in operation now for several decades. Obviously, the technology driving these vehicles has evolved, but in most cases, these systems, they work solidly. They work solidly, providing the environment is adapted to the navigation technology, and the fleet management tool is solid. Equally, there are now a growing number of automated vehicles that are designed to work fully outdoors. And this is what we can start seeing onto the right-hand side of this page. So, for example, AGVs have been in operation at some seaports for several years, and automated systems are now slowly starting to appear in fields such as agriculture, construction, and mining as typical examples. So if we then move to the ecosystem, today in material handling, what we see is that in most cases, to move materials from indoor to outdoor and vice versa, for example, to move materials between buildings, this requires actually 3 different solutions. First, you need an indoor AGV system that will move materials to the door. Then, an outdoor system, usually manual today, will pick up these loads and bring them to the third building. And there, a second indoor system that retrieves these loads for internal distribution elsewhere. Obviously, this is an expensive and very inefficient approach. And until it can be solved, it really threatens to slow down the growth of automation, since the outdoor-indoor use case is rather common, as you know. If we now move to common use case here, to give you example of what we're talking about, when moving loads between building, you can see that in steel manufacturing, or to move material, components, and finished good between production and logistic buildings. If you just use these 2 kind of cases alone, these 2 cases, they will span against numerous markets and industries. So you can see there that indoor and outdoor is something that is spanning everywhere. So what we would like to show you now is to examine the specific challenge and the potential solution. The challenge today is twofold. First, we have an indoor system. Whether these are driven by natural navigation or laser triangulation, they will struggle to navigate outside due to the lack of references that are used to calculate the vehicle position. By contrast, if we now look at indoor-only system, these are driven by some versions of GPS or GNSS, often with an RTK, and simply those cannot function inside since there is no GPS signal inside. So what's the goal? Well, the goal is to incorporate these 2 technologies into one navigation stack. And then we will allow the vehicle to work indoor, outdoor, and most importantly, make the transition smoothly between the 2 environments. The solution, this requires sensor fusion. Effectively, it's taking the data from 2 different positioning systems, natural navigation and high precision GNSS with RTK, and using whichever is the most useful. At BlueBotics, we call this "and everywhere." Let's take a deeper look. I'm going to show you a little video that will explain this very well.
AGVs are proven to boost productivity and efficiency in indoor environments, but outdoor operation was traditionally a challenge, even for vehicles driven by natural navigation. The lack of visible features outdoors made it difficult for a vehicle's navigation system to accurately calculate its position. This meant installations were more complex, took more time, and often required extra infrastructure. And Everywhere by BlueBotics solves this problem. making outdoor AGV operations just as simple, robust, and precise as those indoors. Ant Everywhere achieves this breakthrough by adding an extra source of data, GNSS with real-time kinematic positioning. First, a fixed base station installed on site receives positioning and timing data from GNSS satellites. This base then corrects this GNSS data before sending these corrections to an Ant Everywhere receiver on the AGV. This process transforms GNSS's usual accuracy of around 3 meters to centimeter level, bringing precise outdoor positioning information into Ant's navigation algorithm. All of Ant's sources of positioning data run concurrently. Ant then uses whichever data is available. For example, inside a building where features are visible, Ant navigation uses its usual odometry, IMU, and laser scanner data. But move outside, and because fewer features are visible to a vehicle's lasers, GNSS starts to play a stronger role. Head further away and features are no longer visible at all, meaning GNSS data is given priority. The transition is seamless. Whether transporting payloads between buildings or linking logistics and production sites, Ant Everywhere opens AGVs up to a wider range of industries than ever before, from steel and aluminum production to airports and many more. As early users confirm, Ant Everywhere truly enables a new era of AGV and AMR operations.
We installed an Ant Everywhere AGV at Barcelona Airport and customers from many other industries also use it. Just think how many organizations have processes going into and out of warehouse.
Ant Everywhere is compatible with every type of Ant navigation, bringing the flexibility of indoor and outdoor operation to every producer of Ant vehicles. Ant Everywhere. Let's go outside.
So after showing this nice video that explained the first major problem we see, I'm now very pleased to give back the presentation to Nicola, who's going to talk to you about the second challenges, which I am sure your companies are also trying to address effectively, which is the growing needs for multi-brands field. And this is what we call interoperability. Nicola, back to you.
Thank you, Jacques. So we were happy to show this application outdoor because it's a market, or let's say a market segment that is difficult to assess in terms of volume right now, but the demand is very strong, and the fact that there were no solution to combine indoor and outdoor was a real roadblocker. So now that we have a solution that enables it, we will be able to see how the market evolves. As Jacques said, now we have the second point, which is interoperability. What is interoperability? Is about having different vehicles that can work together. And while this is not necessarily a challenge when you start automating, because normally you start automating with a single type of vehicle or a single product, it becomes more a problem when you have to automate large plants or even maybe for international companies that have plants everywhere. That's why basically there is a dream, the dream to be able to bring everything working together. And there we did not cite the person because we just saw that during a show, but the logistics manager of a very large automotive company in Germany was saying that today there is no supplier that can provide all the automated vehicles they need, this company. And he was saying that even if tomorrow there would be one supplier that is able to deliver all of the models they need, then this would not be so easy because their own purchase department would be kind of scary, being dependent on a single supplier. So this question of making different machines working together is really key. Now, the problem is not new, and this problem has been tackled with different approaches over the last years. The first more simple approach that's been used is what is called interlock or traffic light mechanism that allows two different systems to work together. How does this thing work? So basically, you have two systems. So you will have a vehicle that is, or a fleet of vehicles that is controlled by a fleet manager, let's say the orange one, and you have a second fleet that will be working controlled by the blue system. So there you have different vehicles that have to work in a plant, let's say automotive. One will move pallets, the other will move something else. And you have a place in the plant where there is a potential conflict because you have to share space, you have to share crossing or segments of movement. The way of solving that, so that I would say the historical way of solving that, is to use what it's called an interlock, which can be seen as a traffic light as we have when we drive our cars. Basically, when the orange system has a vehicle that has to enter the red part, it will ask the blue one, hey guy, can I block for me this part? And it will get an answer. So a kind of handshaking between the two systems. The blue will say, fine with me, you can block it. It will block it. It will let the vehicle go through. And when it's exiting, I say, I'm fine. So now I release it. That's the classical interlock approach. The first time we encountered this challenge was when we started working with Toyota Material Handling in North America. Toyota Material Handling had in North America, a large installation base of magnetic tape, small mouse vehicle, as they call it, so vehicles that go under a cart and they pick it up with a pin. And all these vehicles, they were using indeed magnetic tape controlled by their own fleet manager. And Toyota started working with our technology. So we do, I forgot to say, natural navigation for any type of vehicles. Natural navigation means that you don't need to put tape, but you use the laser data to create a map and to navigate without any infrastructure in the environment. And the challenge of Toyota Material Handling was to add vehicles in sites that already were operating the old ones. And that's why we implemented with them this interlock mechanism that allows the old tape vehicles to work still the same way. And then we have exactly this concept of the red nodes that can be shared between the subsystem, the new one with our technology and the old one with the tape technology. So again, that's option number one, which works. The downside of this one is that it doesn't allow to have a global optimization. You can only optimize the two different systems separately, but the optimization of the whole is not possible. The advantage of this solution is that it's very simple and pragmatic to put in place. Now, what's happening in the market is that there are initiatives to solve this problem in another way. And these initiatives are by proposing standards. So what does it mean to have a standard? If you remember what I told you a few minutes ago, we are talking about having different fleets of AGVs with their own fleet manager. That's what happens today in big plants, with the problem that it's difficult to synchronize them. So the dream of the standard is to come up indeed with a communication protocol standard that allows to have a single standard fleet manager system, a supplier that can provide this. And then by using standard communication protocol, this allows to talk to all the vehicles and coordinate the work of all the vehicles, even if they are from 3 different suppliers. So this standard initiative started a few years ago. Today, they are defined as having different level of interoperability. The level number 1 is what is called the monitoring. Monitoring is basically not controlling at all. It's just seeing where the vehicles are and having their status. This can be interesting for an end customer, because if you are an end customer and you have 3 different fleets working, you would like to have one aggregated visualization of what's going on. So level 1 is interesting to monitor what's happening in the plants. Level 2 is more than that, is what we were discussing before. So it's about really having routes that are shared and that can be used by different vehicles. And level number 3 would be to have really a global optimization of the different fleets and the different delivery of material all in the plant with a single solution. Now, if we take a look about what's going on with these initiatives, there are many. These are the most relevant, and there are a few more coming soon. The most developed one is the VDA 5050. So VDA is the name of the German association for the production of cars, so Verein Deutsche Automobil and something like this. And the standard has been developed by the German Association of Material Handling, so VDMA, which we are, by the way, also part of it. So they are working on level 2. They have today something that is partial but already deployed, with some challenges, because this results in the fact that the standard is not completely done indeed. And it means that if you want to make a vehicle type talk with a fleet manager using VDA 5050, you can use what is available, but you will have to develop custom specific software for every vehicle type. So that's what they call the dialects, which means an investment for every vehicle type you want to integrate. So that's one of the limitations of the VDA 5050 today. The second limitation is that VDA 5050 only defines the communication protocol between vehicles and the fleet manager. And this has the drawback that there are no tools to define what a vehicle should do, resulting in the fleet management system that has to use its own tools to create the project of the plant. And every single vehicle type or vehicle technology, they also have to create their own project for the plant. And then all of these guys, they have to sit together to make sure that when they communicate the commands from the fleet management project, well, that the vehicle, every vehicle type, really do what they should do. Because again, the different projects are generating with different tools, and only the communication is defined. So that's today quite a hurdle in terms of cost. Finally, another challenge that we have now is that these standards are rather new, not completely finished, and this means also that they will evolve over time. And because of this, we have a problem of backward compatibility. So we have no guarantee that this will be compatible in the future, which is, again, a big limitation. Now I really have the sunshine coming into my eyes, so give me 2 seconds, I try to correct that.
Thank you. And as we're going to Nico, I'd like to remind you all that you can drop any questions into the Q&A box at the top right of the screen. I see we already have a couple of questions, which we'll get to in a minute.
So sorry, this happens, of course, only 20 seconds per day, and I did not realize it was exactly the time when we have our presentation. Back to the standard. So I was describing the disadvantages of the VDA 5050. Of course, the advantage is that it enables interoperability. And about the other standards, which are the American ones, so in US, the Mass Robotics is defining a standard that should do the same, but they are still at level 1 for the moment. It's really only an early concept. Then we have Open Robotics, Open RMF, that has been developed in Singapore first, and now it's an open source project. And finally, the Chinese initiative. And I would say all of them are even much less developed than the VDA 5050. So interoperability with interlocks is pragmatic, but doesn't allow to have a global optimization. And still you have many fleet manager, which is complexity. Standards are not yet there, and using them is today a risk in terms of cost and in terms of being future-proof, because we have no guarantee about backward compatibility for the future. What is another alternative? That's what we would like to talk about now. And we call these ecosystems. So what is an ecosystem? It's a system that allows to have different vehicles type, different brands even, to work together in a single system. So the same technology, but that is really putting together different vehicles, different brands, with a fully integrated solution that would then allow to have native. So it's not that you have to build up from a new protocol or a new system. It's really from the beginning that you have this kind of characteristic to be interoperable. And this allows to have performance. And of course, what you would like to have is a wide choice of vehicle types, which is the case promoting ourselves, which is called Andrin. Basically, all of our customers that can work together. We are talking about more than 150 vehicle types that can work together. And here, the video you're seeing is the demonstration we have in our office that we use on side as a demonstration, and on the other side, we use it as a test before we release a new version of the software with to run all of this system for 7 days, 24/7 without any. There's an interesting point that has to be the standard with the native ecosystem. The standard by itself is aggregating different, as you saw earlier in the slide, the different technologies normally have their own fleet manager, and every different fleet advantage of the characteristics of the technology, maximum amount of value. Now, if we want to cut away all these different fleet managers and to take what is the least common denominator between the different technology, we will also give up value. So basically, if you take a single technology supplier or vehicle supplier with their fleet manager, and you take 3 of them, every single technology will have some special feature that you will not be able to use if you try to use a standard that uses indeed the least common denominator. And ecosystem is better in these terms because the ecosystem will be indeed working with the same technology, and working with the same technology enables using the totality of the functionality of technology. We are ourselves convinced that this is a good way to go to bring the highest amount of value to the end customer. If we try to look ahead, what is supposed to happen? Which approach will win? It's difficult to say. I mean, the truth is that no one knows the future. Is that single brands? There are a few really large vehicle suppliers in the world, like let's say, of course, Toyota Material Handling, but also JBT or Beta Tanta in Italy. So these are really large companies. Will these companies take over the whole market? Or will the standard take over? One of the standard will be the winner, which would result in the automatic guided vehicle being kind of commoditized, and so having many different brands of the vehicles, all using the same standard, with the drawbacks I said before, so giving up some functionality and some value to use the least common denominator. Or will an ecosystem or several ecosystems win? Probably will be a mix of them. We don't know. And for BlueBotics, for us, that we are today more working in an ecosystem, well, keep calm. We are Swiss and we want to stay neutral. So that's why on one side, indeed, we are pushing for our ecosystem. But on the other side, we already implemented the standard VDA 5050 in order to be compatible with VDA 5050 vehicles on the market. So we are kind of playing at least on 2 grounds, and then we'll see how the market develops. I try to give you an overview about the interoperability question. Now, of course, we are open for your questions.
Great. Thank you so much for that, Nico and Jacques. We really appreciate you sharing your time and expertise with us. So we have several questions from the audience, and the Q&A tab is open for everyone to drop their questions into. First of all, we have a question box itself that you mentioned putting in vehicles. So the question is, do you build the navigation hardware from the semiconductor level, like what Zappi does for inverters? Or do you buy modules such as sensor modules and so on them to build your navigation hardware?
So I think this I can take it. So thank you for the question. Unfortunately, we are not as good as the other Zappi group companies, so we are not building up the hardware from the semiconductor level. That's not what we do. Now, our software is more a complete software, a rather complex software with an operating system, etc. So what we use is really a standard industrial computer, which is a computer on module. And then we work with suppliers that develop for us a PCB to have the connections we would like to have. And finally, we have other suppliers that assemble this complete PCB with an I/O board that we have designed ourselves, but is produced by 3 different suppliers in Switzerland. So it's more working with good suppliers. And we are mostly a software company more than an hardware company. But it's true that we have our own hardware. And the main reason for that is that it's not so easy to guarantee quality if you want to work on many different hardware platforms. So for the moment, we have our platform, which is based on a standard computer, industrial computer, just to be clear.
Thank you.
I hope this answers the question.
That answers the question. If not, drop us another one and we can clarify. All right, we have another question here from Julian R. Can ant-driven AGVs be compatible with the VDA 5050 protocol at a vehicle that is without using ant server? So this is a request that Julian has faced with several different tenders from large car manufacturing companies.
Yeah, thank you, Julia, for this question. The short answer is no, not for the moment. What we are doing right now, we can be completely honest, is that we try to give advantage to our customers. Our customers are vehicle makers, and we try to work against the commoditization. So the point is, we will maybe be compatible soon also, but this depends on how many requests we get from our customers. On the other side, for the moment, we try to strengthen the position of our customers because we allow them to, in this ecosystem, to play together and to cross-sell even vehicles to each other and to take advantage to the maximum functionality that our system can provide. So again, that was a bit longer answer. And the short answer is not for the moment, but soon it's possible if needed.
Great, thank you for that, Nico. Now we have another hardware question. Do you use vision in addition to LiDAR? And if so, do you need NVIDIA processors?
So there are things that I cannot tell you, otherwise I will have to flash you at the end of the session. So a few secret things. But let's say that today we are indeed mainly based on LiDAR. We already use 3D cameras and other systems mostly as add-on for safety. So this is something that we have provided interfaces for our customers. And of course, we are also taking a look to what's happening today with vision. We see on the market there are very few companies that are using visions for real. And I would say almost no company that is really successful with that. But I personally think that vision will be the next step. The question is more when. Is that in 2 years or in 10 years? If it is in 2 years, we are maybe already late, or maybe we are doing something and we don't tell you. And if it is in 10 years, we should think about other things in the meantime. So that's a bit the question about the vision. About NVIDIA, NVIDIA is providing great processors. Now, we have an heritage that is coming from being extremely careful about how we program software, how we use resources, being both memory, CPU usage, etc. So we are in the lucky situation that we don't need the great power that the NVIDIA processors provide. Maybe we will in the future, but for the moment, we work indeed with industrial solutions that they have a huge advantage. They have what they call, how do they call that? Well, the guarantee that you can get exactly the same for a minimum 15 years. So we changed the generation 2-3 years ago. So for the next 10 years, we can have exactly the same processor. And this is not exactly, but almost allowing me to go in retirement before I have to change the hardware. Unless we need more vision system in the near future, and then NVIDIA would be a very good option.
Thank you for that, Nico. I hope that answers your question, David. And for everyone, we do talk a little bit about how BlueBotics navigation works over on our blog. So bluebotics.com/blog is where you'll find a couple of articles which talk about it at a level which, say, I can understand, for example. So they're a good starting point, and you can get in touch with us if you need more details for a specific point there. Now, Nico, I have a question for you myself. You were very political when you said that you were staying neutral on the idea of who's going to win between single brands and an ecosystem. But if I had to push you there, which one do you think will prevail in the end?
Well, again, it's a difficult question. Let's take it that way. Since I have, a very long time ago, I was a kind of scientist, I will answer with probability and not with a single answer, because I will not be able otherwise to answer. Now, if I would have to bet on successes, given what I see right now with the standards, I give them very little chance to succeed. If we would have an existing standard that is full and completely done, and you can push one button and it's there, this would probably work. The truth is that it's done step by step, and that's creating a huge amount of overhead and costs that are kind of hidden costs. And let's say that the dream that the standard wants to sell us, maybe we get it in 5 to 10 years. In the meantime, the question is what will happen. So personally, I think that in 5 to 10 years, we will have 3 to 5 ecosystems that will have 80% of the market. That's my prediction. I would say this prediction, I give it a 70%, 20% the standard, and 10% anything else that I don't know now.
Still quite a political answer, but I think we got a little bit more.
Yeah, but with some probability.
No, that's great. Thank you. And we have another question as well. We talked about the 2 biggest AGV challenges as being outdoor operation and interoperability. Do you think you could speak about how those 2 are enmeshed at all? Or is it that once you've solved the problem of interoperability inside, it automatically works outside, vice versa?
Jacques, do you want to take it, given that you are the outdoor speaker?
I think that's a great question. It's all depending on the vehicle capabilities. So if you have needs for inside, type of vehicle will be probably very different than the one that will go outside as well. So here you can combine forces of both type of vehicles, and sometimes one brand will not be able to meet one of the requirements. And that's where interoperability will also play a huge role. So it will facilitate this kind of flexibility. And that's really the strength of the system here that you can see. It's how do you make life easier according to the capabilities of the vehicle provider you already have. And if they don't have it, we have solution for the next missions. So the answer is it's complementary, absolutely.
If I can jump on that, I was thinking while you were explaining that, if we take a look to the picture you were presenting, Jacques, most of them were quite large vehicles. So it seems today, probably to have return on investment, you rather take large vehicles. And one reason is also because indeed you don't have this seamless transition indoor-outdoor. So in order to have ROI, you need to transport big things. I personally think that soon we will see more and more pallet vehicle, forklifts, that will be requested outdoor, because as soon as you can bring down the investment cost, ROI will also be quicker, and you will maybe be able to use smaller, more flexible vehicles if the technology enables that. And this goes again back to interoperability, because you may have sometimes big vehicles and forklifts that will also have to work outdoors. We'll see what happens. See you in the future of electrification session 2028, and we will answer this question again.
Fantastic. And Nico, you mentioned ROI there briefly. We have a tool which we created to help out end users. It's on antdriven.com and is ROI calculator. In a moment, I'll drop that in the chat, so if anyone's interested, they can have a quick look. I wanted to also ask about the possibilities of what these two challenges may open up. So there's the flip side of a challenge, isn't it? Is the opportunity that it brings with it. So we talked a little bit about how airports are one of the main use cases for outdoor AGVs. Are there any others? And do you see any other use cases that might be opened up for interoperable vehicles as well?
Maybe I just make a comment first on the airports, and then I let Jacques take some other examples. But airports, I found them extremely interesting. Airports, we had discussion with the Zurich airport a few years ago, 2-3 years ago. They are redoing all the suitcase, luggages, logistics, and they were mandating some experts to assess how to do it. And what we learned is that they are using the same technology and the same processes as 30 years ago. So the automation is at a certain level in airports, but it's really the same since 30 years. So I personally think that both in terms of outdoor, but even in terms of interoperability, there are really a lot of processes that can be done in another way, in a better way in airports. Now, the challenge is that you need airport experts to match the needs of the airports with the technology that is available today. So that's why we at BlueBotics are convinced that the system integrator is the one that plays one of the fundamental roles in this market, because it will be the system integrators that will understand the needs and indeed understand how to match technology and process in order to create value. Jacques, any comments on your side?
I think from the little experience I'm gaining in this market, I see a huge interest from all sorts of environments. And we saw that in the presentation. It's expanding. I mean, from the vehicle capabilities, first of all, with the forklift becoming here as well, from the needs of, let's talk about recycling. So on the recycling, there is huge needs of this with conditions that are kind of difficult. So all in all, what I'm seeing here is an ongoing need to know where are the payloads going, how are they managed from one place to the other, and it's a increasing demand of simple and efficient solution that will work in both environments. And for me, what I see here is we have great customers with fantastic engineering capabilities and creativity. What they just need is a reliable navigation system that will enable the transition. And after that, it's just a question of really working together to find the right solution. So any industry, any solution is feasible, and little by little, it's gaining the confidence to do that.
And by the way, let's not forget agriculture. Agriculture is not easy because the requirements are high, but the need and the potential is huge because we have, remember that agriculture has been one of the first markets that have been highly impacted by technology and automation. About 120 years ago, 90% of the population was working in agriculture to create enough food for everyone. Now we have only 2 to 4%, and we are struggling because we don't have enough people anymore to generate the food that we all want to eat. So I think agriculture is another hot topic that may take a bit more time because indeed the processes to be automated in agriculture are a bit tricky, also in terms of safety. But I think it's another place where automation already is there, but there is still a lot to do.
Yeah, and we were talking about that with some Asian customers, where the demography and the farming is really in jeopardy. Average age of the farming people are over 74 years old. And suddenly here, there is a gap of more than 10,000 farming capability. So they're turning into outdoor capabilities. So
Japan, yes, exactly.
Japan. So there is this need in terms of demography, in terms of where we're moving as a society as well. If we want to feed, then we've got to be able to sustain this very complex industry. And this is where the automation of these processes will play a key role moving forward. And that's just two examples I'm giving you here. And it comes with some challenges, as Nicola said. So
Absolutely. That's the two sides of the same coin. You have the challenge and the opportunity. And that leads on nicely to another question. In your experience, how do indoor/outdoor vehicles cope when going indoors after driving in poor outdoor conditions? For example, there might be some condensation on lenses and so on.
That's a good question. I'm wondering if Mike is part of a laser scanner supplier and wants to do some advertising. No, jokes apart. Well, no, it's always a good question. Going outdoor means having most of the components that are IP67. Now, the truth is that the components are not IP67, most of them. So you still need a cabinet that is able to handle temperature, humidity, rain, etc. On the other side, the sensors themselves, at least the safety sensor, they must be outside, because if you close them in the cabinet, they cannot measure. So those are the sensors that have to play with that. There are dedicated solutions for this that handle both the difficult conditions like rain, snow, fog, etc. And on top of that, to work against condensation, they have, how do you say, an heating system that makes sure that you keep a more or less constant temperature to avoid condensation. There are some challenges that are not yet solved, not even in indoor-outdoor, but it's more when you go into cold places. And there, if you go from plus 20, 30 degrees Celsius, sorry for the others, and then you go to minus 20, there indeed, no matter which technology you use, it's tricky not to have condensation. So indoor-outdoor, I would say it is more or less solved with some products that are available today, but you have to choose the right ones.
Absolutely. And just to add to that, it's not only vehicles working outdoors that have to face tough conditions. We have vehicles working in, I believe, and I just wrote an end user case study, which was about packaging potatoes, which sounds quite easy, but apparently these vegetables throw off a lot of dust, and the team had to include in their workflow manually wiping off some sensors to make sure that everything was still working A-okay. So it's not just outdoor vehicles, and it's not just snow you need to worry about. These vehicles are working in all sorts of tough conditions.
Yeah,
Right.
so Rachel, we have a customer that had to handle in a candy production. They had the problem with sugar around, and what they did, they did around the safety scanner an air flow that was going out, so kind of blowing air to make sure that the dust of sugar is not going on the sensor. So sometimes you have to find creative solutions to handle this kind of things.
What an absolutely delightful problem to have. If only all our problems were based around slightly too much sugar. All right. So are there any more questions? If so, please drop them in the chat. Otherwise, we're coming up to the hour. So we'll start wrapping up. Nicola and Jacques, I'd like to thank you once again so much for sharing all your time and your expertise with us. I know I personally learned a lot today. And everyone, as I mentioned, this session has been recorded and will be available. So if you would like to watch some of it again, if you have to drop out halfway through, or if you'd like to pass it on to a colleague as well to share the insights, that will be available to you. And we just had a note saying cleaning robots could also definitely help the fleet not to have lots of candy dust.
So that's not a question, that's a comment. I'm wondering who is bringing this comment, but you are absolutely right. An alternative to the blowing system on the laser is to have cleaning robots for that. And by the way, we have a great customer that is compatible with the ecosystem and can provide the cleaning robots that work with all the other AGVs. So if you have questions, don't hesitate to reach out to us.
And that shows us as well the opportunity of an interoperable fleet, so it can help solve the challenge of too much candy dust. So everyone, thank you so much for joining today. I'd love to invite you to keep watching some more sessions at the Future of Electrification Conference, which is continuing today and tomorrow. Nicola and I are presenting tomorrow about the current and future landscape of AGVs. So I'd like to invite you to join that session in particular. But once again, thank you very much. If you have any final questions, do drop them in the Q&A and we can answer offline. Thank you all once again. And we look forward to seeing you at some more future electrification sessions. So